Hi, my name is Mutlu Ahmetoğlu, and this is my performance video for our EE361 Lab Experiment 2. Let's start with the first question. It asks, what is the reason for the discrepancy between the current RMS values of the oscilloscope and the wattmeter? And let's see the circuit schematic here. The oscilloscope measures the current through the ports C and D. C is ground and D is the channel 1 port. And how it finds the current is that it multiplies it with 2, since there's 0.5 ohms of resistance here. And the wattmeter measures the current through its ammeter here can be seen. So what is the difference between what is the reason for the discrepancy? Now, the reason is that if we look at our way of finding the current with oscilloscope, we see that we use the DC resistance of this 0.5 ohms instead, but although our signal is AC signal, so we should use AC resistance, which we know is 1.1 times the DC resistance. So if we use instead the AC resistance for this resistance, we find that the current value is 1.1 times more. The value we find is 1.1 times more than the actual value. So the actual value turns out to be equal to what the wattmeter has found. Let's go on with the second question. Why do we use only the BH curve for finding the core losses? Well, we know that there are two types of losses associated with the cores: eddy currents and hysteresis losses. And we know that both of these present themselves as an increase in the hysteresis loop area. So how do we find these? We find them both by looking at how they increase the hysteresis loop area. So we only need the BH curve to find the core losses, because both of them present themselves in that way. And also in this experiment, it is said that we can ignore the eddy currents because there's so little compared to the hysteresis losses, which makes it even more meaningful to only use the BH curve to find the core losses. And finally, we come to the third question. Why do we use multiple input voltages for the open circuit analysis, but only one input voltage for the short circuit analysis? Well, it asks why do we use like 50, 100, and etc. up to 220 volts for the open circuit analysis, but only one voltage and therefore power value for the short circuit analysis. Now, to answer this question, we should look at what we find with these tests. With the open circuit test, we find RC, the resistance that is symboling or that substitutes the core losses, and XM, which substitutes the magnetizing current in the core, and which are both dependent on the saturation of the core. What this means is that they're depending on whether the core is saturated or not. That's why we take multiple values of voltage. The value we start with 50 volts presents no saturation in the core, whereas the value we finish shows big saturation value. And we see that the values change, the voltage input power values change, which results in the change for RC and XM values. That's why we should find them for different values of voltage. But we see for the short circuit test, we find R equivalent, the equivalent resistance of the copper wires, and X equivalent, the inductance associated with the leakage flux. And we see that both of these values are not depending on whether the core is saturated or not. So that's why we only need one measurement, the one voltage measurement and current measurement, to find the input power, so that we can find R equivalent and X equivalent. So these are my answers. Thank you.